Hi there, my name is Michael, and this will be another devlog for my game Radio General. Today we're going to be talking about camera bounds and movable pieces. So, in the previous devlog, I got the camera working, so let's just hit play and I'll show you what I mean. So, I can use WASD to move my camera around, and we have this nice map here. And then we have this ugly border where we don't got anything, this large black space, and I can keep scrolling off into the distance. I can also zoom my mouse out pretty far, so I probably don't want to be able to do that. So to fix this issue of, the user being able to scroll off infinitely into black space, we're going to have to add some boundaries to the map. So right now the way we're moving our camera is through this camera controller here. And very simply, all it does is gets the axis, either horizontal or vertical, and those were the A or D or left and right arrow keys. And the vertical axis was the W or S or up and down arrow keys. So if we want to add limits to how far we can move our camera, or really move any object, what we need to do is add some boundaries, and the easiest way to do this is to actually just use some other objects to mark the boundaries. So let's get two transforms. We're going to need a top left transform and a bottom right transform. So between these two objects we'll be able to make a rectangle, and I'll show you what I mean right now. So for a map, let's make those objects. So let's make top right boundary, and let's make a top left, bottom right. I believe I mixed up there. I believe it is bottom right boundary and top left. Alright, let's rename those. Okay. So let's take these objects, and right now they're just transforms with no components on them. So they're just completely blank objects. So let's position our top left boundary around the top left of the map. So we don't want the user really scrolling too far past this top left corner, and we don't want the user scrolling too far past this bottom right corner. And so we want to limit, the space they can move around, in between these 2 points, so the top left and the bottom right. And between these two, basically we make a rectangle of movable space. So if we clamp our boundaries to say, don't go above y of 4.35 and don't go below of a y negative 4.28, we'll just make it negative 4.3 for symmetry's sake. And we can do the same for x, so like don't go any further than, negative 8. And to the right we say don't go any further than, to the right than 8. So between these two we capture, the boundaries of our space. So we want to move anywhere in between inside this this rectangle. All right. So we have those. Let's assign them to our camera object so it can use them. So here we go. We drag in our objects, top left, bottom right. All right, and now we need to use them. So here's where we get our input, and here's where we change our position. We're now going to have to change how this new position is calculated. So let's not do plus equal quite yet. We're going to say, okay, we're going to go first by x and then by y, changing our position. So we say, take where we are currently on the x and add our x input, and take where we are currently on the y and add our y input. And now we have these new values. What we want to do is clamp them. So we use mathf.clamp, and so the first parameter is going to be the value, the new value, and then we need to put our min and max. All right, so the min is going to be for the left, so this is the x, top left dot x. And the max is going to be bottom right dot x. All right? And of course, I can't just put that. I need to put transform dot position. Actually, I don't need the transform part because it is a transform. There we go. And so this will be for the x. So we don't want to go any further to the left than, the leftmost point, and we don't want to go any further to the right than the rightmost point. So between those two we get to clamp. We get to, clamp our boundaries. Let's just put this on a new line below it so it's easier to see. And we're going to do the same thing for the y. So we're going to do mathf.clamp. And the first one is going to be our value. And we actually need to put a 0 afterwards, finish our vector 3. And so the topmost point, so the min of the y, let's check just to make sure. I sometimes get confused. Okay, so the bottom, indeed that makes sense. The bottom right position is going to be our min with the y, and the top left is going to be the max with the y. Okay. All right, so now we should be able to try that out. And when I hit play here, we'll make sure. Oh, okay. Obviously, I've done something wrong. I see. There's our problem there. The problem was that when you change the camera Z, if you go too far, too close, basically what's happening is this camera is actually in 3D space. And as you move it back and forth, it changes whether or not it's going to see these 2D sprites. And even though, technically we're using a 2D camera, Unity renders everything in 3D space, technically. So what we want to do is actually not change our Z, and I made a mistake there with this 0 here. So we want to take our previous Z position and not ever change it. So there we go. Okay, there we go. All right, so now I should be able to scroll around. So let's scroll up. Okay, there's our edge, and we shouldn't be able to go, there we go. I can't go any further up. I'm pressing the up key, and it's not letting me go any further up. So excellent stuff. So even with zooming, hopefully I won't be able to go, more than half the screen past. There we go. So yeah, I can't go past this boundary. And I'm just going to increase the sensitivity so we can move a bit faster. Yep, that one's working. And this one's working. Okay, and how about the top right? Okay, it's all working perfect. So we've now added boundaries. Now, you may think that half the screen is still this blank space. Well, we need that. Well, that's something I'll worry about later. It's just for now we have simple boundaries. Okay. We can also zoom out pretty far and zoom in. I don't know if we need to change that quite yet. I already have these parameters here for that. Let's go on to our next topic today, and that's going to be you moving unit pieces around. And if you go back to my concept video, hopefully you've already seen that. If not, you might be a little bit confused of what I'm trying to go for. Is the user, there's going to be these units, both enemy and friendly units, on the map, and they're going to be moving around and fighting each other, but the user doesn't see that. All the user is going to see is this map, and they're going to have these basically board game-like pieces that they can drag around the map to represent what they think is going on. And so I'm going to call these pieces, so as in a board game, or a board piece, a unit piece in this case. I made this object right here. And the user is going to have to be able to drag these around and so say, and think to themselves, well, I'm going to put this infantry company in these woods here, or maybe I'm going to move him over to this town, and that's where I think he is right now. So the user needs to be able to drag these pieces around by holding down the left mouse button and moving the mouse. So drag them around. So let's do that. Let's create a new script for that. We'll call it Draggable. And to do that, we're going to use a built-in Unity method called onMouseDrag. So void onMouseDrag. And what this does is when the user is holding down the left mouse button and moving the mouse. So it's called when the user is holding down the left mouse button and moving the mouse around. So essentially dragging the object, which is exactly what I want to do. And so we're going to take this piece of code from follow mouse here. And what this did was it figures out, okay, where is the mouse position right now in terms of screen coordinates? And then we need to use the camera to convert it to world space, because the coordinates in your screen are set, so here's the top left of your screen and here's the bottom right. Well, that doesn't necessarily correspond to where in the heck are those points in the world, because your camera can move around. So We're going to use that piece of code, and we're just going to alter where we are based on that code. Though actually, I'm actually going to, I changed my mind slightly. We're first going to take the vector of that. So mouse world position. We actually want to change a little bit because our point that we grab may have a different z-axis, and we don't really want to change ever. We don't ever want to change our z-axis in a 2D game, else the sprites get too close to the camera and you can't see stuff. Weird stuff pops up. We don't ever want to change the z, so we're going to change the z to be whatever our z position is currently. And yeah, 2D and 3D stuff in Unity, it's a bit weird having this whole z. What's the point of a z coordinate? It is strange, certainly. And now we'll assign it there. All right. So let's try it out. All right, perfect. Okay, so now you can see I'm holding down left button, and I can just drag this unit piece around. Perfect. And actually even drag it off outside where the mouse is. Cool. All right. Okay. So there's one problem though. You can drag this off screen, so you may want to add a collider. I probably will want to add a collider at the edge of the map here, so you can't drag it actually outside of the screen. But that's a problem for another day. Now, one thing that is weird though is if I click even the top right corner of this object here, notice it immediately snaps to the center and starts moving it wherever it centers the object on the mouse. And that's not, that doesn't quite feel intuitive to me at least. It's kind of a, a bit abrupt and jerky. So we probably don't want that. Probably what we want to do is have an offset. So we want to find the offset. So where was the mouse relative to our current position? Okay. So to do that, it's actually pretty simple. Is again, we get our mouse world position here. So we'll just move this up a little bit. And we'll still change the Z to be there. And what we do is we say, okay, take our wherever the mouse is right now and minus wherever we are right now. And this should give us a different vector 3. And the negatives might be off. I may have to change the order of this. We'll have to see. And then what you want to do is add the offset back. And hopefully that'll get us what we want. So let's try that out. It might take a little bit of trial and error here to get with the right negative signs here. Okay. So it looks like it's not quite cooperating here. Let's make sure. Yeah, so it's constantly changing. Okay. Okay, and we're back. And the solution is to actually use on mouse down. And so this method here is called when the user clicks on this object. So left clicks. And so when the user first clicks on the object, which could begin a drag if they start moving the mouse, and actually, because that happens first, we'll actually put it above here to make it makes more sense. So this will happen first, and what you do is you say, okay, well, get the mouse world position again, get where the mouse is in the world again, and figure out the offset here. And we take that by saying where we are currently minus where the mouse is. And then when we go down, when we start moving the mouse with a mouse drag, we use this offset. Notice we don't change this offset anywhere else. We use it because we set it here, and it's a variable from up here. And we use it on mouse drag, and we add it to our offset. So let's take a look at that in action. And notice I click the bottom right, and notice the unit the shape stays there. So even if I click this little corner, I can move it by the corner. If I move this corner up here, I can move it like that. And that's exactly, what I'm looking for. And that'll be it for today.